Good morning, students. In the previous video, we have seen what is meant by optical fibers, what, how is it constructed, or what is the construction of the optical fibers, what are its main parts. Also, we have seen the types of optical fibers based on material used, the variation of refractive index, and all. Now, in this chapter or in this video, we are going to discuss the fabrication of optical fibers. So, precisely speaking, we will be discussing about the process of fiber fabrication, types of optical fiber fabrication. For example, there are various techniques used. The first one is outside vapor phase oxidation, OVPO, then vapor phase axial deposition and modified chemical vapor deposition, plasma activated chemical vapor deposition, and lastly we will discuss about general fiber fabrication techniques, or we can say processes. So let us go one by one. Introduction. Optical fibers are essential components in modern communication system, enabling high-speed data transmission with minimal loss. Why these are essential components of communication system? Because they uses high-speed data transmission. At the same time, the loss of the signal is minimum or minimal. These fibers are primarily made from silica based materials, ensuring high transparency and minimal signal degradation over long distances. The fabrication of optical fiber involves highly controlled processes to ensure uniformity, low attenuation, and high transmission efficiency. Since even minor impurities can significantly impact performance, high purity raw materials and precision techniques are employed. The process of fiber fabrication includes the preparation of high purity glass preform, which are then drawn into fine fiber. So first of all, using the high purity materials, what is done? Highly pure glass preforms are obtained, and then from the preform, the optical fibers are drawn. Various fabrication techniques have been developed to produce high quality optical fibers, with most common method being vapor based deposition process. Now, processes of fiber fabrication. Mainly, the fiber fabrication consists of three processes. First is preform fabrication, then fiber drawing, and coating and testing. So, fiber fabrication consists of three major steps. First is preform fabrication, then second is fiber drawing, and third is coating and testing. Preform fabrication is the first step where a highly pure silica based preform is manufactured using chemical vapor deposition technique. The chemical process used in preform fabrication is generally chemical vapor deposition, where vapors of chemical in predetermined proportion are deposited layer by layer so as to form the preform. So this preform serves as a raw material for fiber drawing. The second step, fiber drawing. Fiber drawing involves the preform to extremely high temperature, heating the preform to extremely high temperatures around 2000 degrees Celsius. So whatever preform is obtained from the raw material by using method of chemical vapor deposition, that preform is again heated to high temperature such as 2000 degrees Celsius, and then at such a high temperature the pre- the optical fibers are drawn from this preform. So pulling it into the thin optical fiber with diameters typically 125 micron. In the coming lecture, we are going to see that normally the diameter of the preform is 1 meter. So, from such a huge preform of having diameter 1 meter, a fiber of generally 125 micron diameter is drawn. Now, the final step is coating and testing. This ensures that the drawn fiber is coated with protective polymer layer such as UV curved acrylate to prevent mechanical damage. Since the fibers are very delicate, having diameter of 125 micron or even less than that, so obviously we should provide it the mechanical strength, otherwise it will get damaged. So to prevent the damage, the coating is done. The fiber is coated with UV cured acrylate. Also, such a coating restrict the environmental degradation of the fiber. Additionally, optical and mechanical properties such as attenuation, diameter consistency, and tensile strength are also tested to guarantee the performance of the fiber. And after coating, testing is carried out. So, in testing, mainly various parameters such as optical properties. Optical property means whether the refractive index is correct or not, core refractive index, cladding refractive index, whether it is light is transmitted by means of total internal reflection or not. All this is checked under the heading of optical properties, and in under the mechanical properties, uh, as just told, the mechanical strength, etc. is its elasticity. We can say that is all checked in mechanical properties. Then attenuation, means loss of signal, how much signal is lost over the transfer of signal from one place to another place, that is checked by means of what we call as attenuation. Then diameter consistency, whether the diameter of optical fiber is consistent or uniform throughout its length, that is also checked. What we call as a diameter consistency, and then tensile strength. Tensile strength means when we pull the fiber, then uh, whether it is performing well or whether it is sustainable to the pulling force while installing the optical fibers. So that is also checked under the parameter of tensile strength. So all this testing guarantee the performance of the optical fiber before it is being actually used in communication. Now then there is a third point is typical types of fiber fabrication. Several techniques are employed in fabrication of optical fiber preform. The most widely used method include outside vapor phase oxidation, then vapor phase axial deposition, modified chemical vapor deposition, and plasma activated chemical vapor deposition. So for this video we will stop here. and in next video we will go discuss all these methods one by one. Thank you.